All right, everybody. It is 10 o'clock, so I want to welcome you all to the NCAT From Research to Implementation webinar series. We've got an exciting topic again today. Today's topic is dialing in an asphalt plant with minimal tonnage. And I think this is so important when we're trying to switch from one mix to another, or we're trying to test some new material. And that's why Buzz was real excited about doing this as well, because his runs are so short when he's building the test track. And so it's very good. I want to remind everybody, please stay muted. If you have any questions, please dump them into the chat box and we'll answer them as we can, and we'll answer them at the end of the webinar as well. So given that, today our guests are Buzz, who's always with us. So Buzz he earned his PhD in civil engineering here at Auburn University with an emphasis in pavements and geomaterials. He worked for 12 years with the Alabama DOT and 2 years in the private sector before becoming NCAT's first test track manager back in 1999. And then in the fall of 23, Buzz has become the first technical director of the Asphalt Pavement Alliance. And so even though he's got a new position, we're not missing him too much. He spends plenty of time with us and we love having him. So our guest today is TJ Young, and TJ is the president of the Technical Training and Advisory Services, which is pronounced TASCO, even though he's got a 2 in there. I love how he's done that logo in his name. But he has over 40 years of experience working in the asphalt industry, including 16 years working for 2 different asphalt plant manufacturers, 5 years working as a regional manager for a materials producer, and since the year 2000, he served as a consultant in the industry. So Mr. Young has also been very active in developing technical materials in the area of mixed production for NAPA, with us here at NCAT, for the Asphalt Institute. He's a frequent speaker at NAPA, the World of Asphalt, ConExpo, and state contractors associations and DOT conferences. He's also authored several state contractor qualification programs in mixed production. So given that, remind you, give us your questions in the chat box. And Buzz, take it away.
Okay, thanks, Travis. Can you hear me okay?
I hear you just great. Thank you.
Awesome. Well, I'm always excited to do these webinars with Travis, and I also enjoy the different guests that we bring in here, and I'm very excited to do this with TJ because he and I like to get together and talk about asphalt plants. He's my asphalt brother and my faith brother, and TJ, appreciate you being here today, and we'll jump right into this really important topic that I think is important to both of us. So the way these webinars go, those of y'all who are regulars know this, but Travis is our moderator. He kicks us off, and then the flow of this is I'll typically provide about 5 minutes of background. Then we'll have someone who'll talk for 20 minutes about research, someone who talks about 20 minutes about deployment, and then we have practical takeaways. This webinar is going to follow that flow, where I'm going to go through some track background. I'm going to talk about the research side, which is our experiences here at the track, and then TJ's going to come in with his practical experience, as he's done. He's had a whole career of plant support work, and I told Travis before we started, he's probably forgotten more about plants than I'll ever learn, and then I'll come in at the very end and talk about practical takeaways. So this is a subject that's super important to me, as Travis alluded to, because of the work that I've done here at the NCAT Pavement Test Track since 1999. And I'm gonna, we rebuild the track every 3 years. We do maintenance within our research cycles as we apply 10 million easels of damage to all the test sections that are on the track. But just the diversity of the runs and the need to get quality quickly is really what made us want to do this webinar, because I think where the content for me, where while I was with NCAT, I ran a nonprofit business for NCAT, and I'm hauling material from all over the country. In the same way, TJ has done work to support industry, for-profit industry, where you can maximize your profit and your competitiveness by minimizing your waste. And that really, I think, is how this topic fits together for both of us. So as I mentioned, we have rebuilt the track every 3 years. Let me see if I can get my box here minimized a little bit. Since 2000, and we're currently running the trucks a little over 8 million easels on cycle number 8 out here. But the big thing is our rebuilds. We have very long truck hauls for aggregates. We long haul aggregates from as far west as Oklahoma and Texas, as far east as Virginia, and as far north as Kentucky. So it's logistically challenging to have loads here when we need them, but it's also extremely costly. So we do everything we can to minimize our waste and to hit quality just as quickly as possible. The challenge is we have to haul enough material so that we kind of account statistically for misfires and for multiple practice runs before we pave on the track. But you can't, we're a nonprofit business, so you can't be flippant about how many truckloads of material you bring in. And we've kind of learned historically, what are the minimum number of loads for very small percentage stockpiles, for example, in mix, but we have to do it with minimum waste. So you need perfection in setup and production, in sampling and testing and interpretation. There's essentially no room for error, because if we screw up any part of that little short list right there, then we get numbers that don't mean anything, and we can end up having a very expensive mill and replacement out on the track, just in order to protect the research integrity. So what I've learned on the track in the work that I've done here is it's useful for minimizing waste and maximizing profit in the real world. And that kind of is the connection between the content that I'm going to talk about and I think the content and the value that TJ is going to bring. That if you use the principles that we're going to talk about today, you can prevent the waste of raw materials. That's virgin aggregates, that's recycle, that's binder, that's additives, and that's a really good sustainability action to take. You can minimize your plant downtime in startup and shutdown and in transition. And that's time, that's tonnage, that's energy, that's labor. So there's savings associated with each one of those things. And you can optimize the use of available trucking resources. And that's something that's important to us, when we're building the track, because when we kind of schedule our day, just like y'all do in the real world, when you're paving for profit, we schedule trucks and we need to minimize the scheduling of our trucks, but we have to have enough. And so the limiting transitional waste is a super important part of that. And you can earn pay if you do all this stuff correctly. You can earn pay in the laboratory with high quality mix, regardless of which truck you test, regardless of whether it's the first truck or the fourth truck or the 10th truck. And we typically, it's not uncommon, I would say, to start a little sloppy and to not necessarily check all these quality boxes, because you're not going to sample until maybe the third or the fourth truck. But we don't have a third or fourth truck here at the track, so it's really important for us to hit quality with that first or second truck that rolls out. So in terms of that's all background. In terms of my contribution to the webinar today, I'm starting out with basic plant maintenance, and that begins with a burner. I think calibration of the burner for optimum efficiency is really important. And it's not. And you might think, well, why does that matter? Well, if you're trying to start up fast and get temperature fast, then the efficiency of the burner is extremely important in order to do that. Something that we often don't think about is replacement of belts that have wear holes in them. You might think, well, it's a small hole, losing a little bit of material. That's not a big deal. I'm going to wait to replace that belt till I get in a better spot on my maintenance schedule. But you're going to lose fines when you have holes in your belts, and you're going to get a little bit of segregation, a little bit of loss, and that can hurt you when you're trying to hit quality quickly. When you're running mixes of different sizes, this is kind of tough to do, but you really need a scalping screen that's the right size for the mix that's being produced. And if you've got a range of mixes that you typically run, you're going to have a scalping screen that's going to have a lot of application across those mixes. But if you jump in with a vastly different size, like if you never run preservation thin lays and then suddenly you come in and run a 475 in mass mix, then it would be extremely helpful to have a smaller size scalping screen if you can jump in there and get that done in a profitable way. Flight design and drum speed is important for optimum drying, and that keeps you from sending too much heat to the bag house and overheating the bag house and creating all kinds of other issues. So the variable speed drums and the new flights that are available are very, very useful for that. You need to go in periodically, and it just kind of depends on the type of mixes that you're running, but clean out the hard, rich, built up material inside the drum, and that where that happens is going to be a function of what type of drum that you have. For us, we run a double barrel green Aztec plant, so the outer shell is where we have to really focus on maintenance, and that's typically done on Saturdays. When the plant that we essentially rent to rebuild the track is not being run. But if you don't keep that buildup clean, that stuff's going to chunk out, and it's going to create all kinds of quality issues for you out on the roadway when you haul out and you place. This is a big deal for me because it burned me one time. But you need to monitor your batcher for metal wear. We had a hole in our batcher metal, and that I was not aware of, and so I was just suddenly had this really intense segregation in the back of my trucks, and I was like, what is going on with this? And it turned out that there was a hole in the batcher that needed to be repaired. And so when you have mix that's impacting the batcher side, where that impact occurs, you get a lot of abrasion and you get a lot of wear. That can create segregations that's so bad that it's going to impact your test results, and it's actually going to impact the mat, even if you do have a buggy. The last 2 points are really big for me, but belt and AC calibration versus just kind of offsets, and we can, in the heat of the battle and in the kind of the crunch to get our work done with the workforce development challenges that we have. Oftentimes we start up on a big job and then we make adjustments based on our QC feedback. Well, you got 1,000+ tons of mix out there potentially by the time you get feedback on QC. So you need to calibrate the belt and the AC and the weigh bridge. And you need to do it calibrate the AC pump for different binder grades. And so that's a big deal for us because we're constantly bouncing around using different binder grades, different types of binder. In some cases, wet rubber modified binder, things like that, highly polymer modified binder. And when you change AC, you need to calibrate the AC pump. And this sounds like a lot, and you might be thinking, my gosh, that's a lot of stuff to be thinking about. But if you want to hit quality fast, in my opinion, these are kind of the maintenance basics. And for the rest of the little bit of time that I have here, I'm going to focus on the weigh bridge and AC calibration in the bins. So starting with the liquid asphalt pump, it's much better to adjust for specific gravity on the front end than it is to just start up running mix, let the lab measure binder content, and then make a tweak to the plant based on what you measure. For us, we have a weigh tank at the plant that we have typically used to build a track since 2003, and this tank is sitting on load cells, so we can pump into the tank, and then we can relate the volume of material pumped to the weight of the binder. And of course, probably everybody in this webinar knows, we design mixes gravimetrically, but the plant uses gravity to measure the solid material that's in the mix. But for the liquid asphalt that's in the mix, that's a volumetric feed system. So we use this tank to relate weight to volume, and they don't equal each other necessarily. So it's important to have that calibration and to not just use feedback to do it. So we've tried different things. Just maybe this should have been obvious. Maybe it's obvious to TJ, but we thought, well, maybe we can use our unload pump as a calibration, as a verification to kind of tweak our AC pump for the plant, the feed pump for the plant. But what I learned was that the unload pump is set up, that system is designed for speed, not for accuracy. So it really doesn't have any value. So you can't relate the feed time to the weight of the tanker or anything like that in order to kind of cheat on the AC calibration. You need to calibrate the AC pump annually, and you really need to do it if you want to hit fast quality without hitting it with QC feedback. Anytime you change the binder. So if you change from to a ground tower rubber modified, there's a big change in a volumetric feed. Sometimes with wet rubber modified binder, you certainly need to calibrate the pump when you do that. So many plants have a slave pump and a drive pump, and so there's one of the pumps is pushing and the other pump is measuring. So it's verifying, it's checking itself to make sure something's not wrong with the push pump, with the drive pump. So there's two measurements that the plant is picking up on. One of them is the pump, and the other one is the tachometer, as it's called sometimes, typically in the plant. Those need to be the same pump. So you don't need to mix and match pumps, because you're not going to get a good comparison when you do that. When you swap over, it's a good idea to flush the pump out. When you make that change, you might need a special pump. You might need an oversized pump if you go to some kind of an exotic recycled tire rubber or ground tire rubber modified binder, and it kind of makes sense. You're pumping volumetrically, and now you've got compressible elastic particles that are floating around in that binder, so it can behave differently, and you may need a bigger pump in order to push that material. I don't have any experience with micro motion sensors, but somebody pointed out to me that some states require these, and these are just special sensors that help you to measure the flow of asphalt into the drum. TJ may have some experience with that, but I've never worked with that technology. What I have worked with that I really like, and this is not something that our plant that we use here has, but when we built test sections up in Minnesota, the Dillman plant that we used, Mark Marietta's Elk River plant, they had this, but they had really sensitive pressure transducers installed at the bottom of their vertical AC storage tanks. They were very sensitive, so they had nice, like I'm used to sort of the radar based or sonar based depth measurements in AC tanks that are just sort of ballparks that sometimes can get you in a little bit of trouble if you're trying to figure out how far you can run with the binder that you have. But these depth measurements were very, very precise, and I think if you've got a system like this, you can actually use this to sort of continuously recalibrate your AC pumps based on the volume of material that you have fed out of the tanks with those measurements. Liquid additive pumping, many states require you to any liquid additives that's going to be in the binder, they're required to be pre-dosed when it leaves the terminal. We don't do that because we have we're running mixes for many different states with many different binders or many different additives. So we have a multi-port injection system, and we run this standalone feed pump. This pumping system was donated to us by Ingevity. A lot of companies donate a lot of things, and that's a high-tech feed system that was donated, and then that Ingevity pump. And those pumps are really nice because you have a set point, and then they have a flow measurement, and so kind of like the AC slave pump and the drive pump, they match up in order to hit the designated flow rate. But this is really easy to check, and so all I do is go out there with a black magic marker, permanent marker, mark the line in the tote tank that for this material that I'm feeding, and then look at how many tons I've run, and then look at how much drop there was in that tank, and I can verify that my dose rate is precisely what I want it to be. So that's kind of my big stuff. Well, I got some more content here. So on weigh bridges, this is our weigh bridge at our plant. And regarding the weigh bridge, you can calibrate this with scales and trucks, and you can also check it with yield. Annually, you need to calibrate it with trucks, meaning you're running material across that bridge, and you're bypassing it, not dropping it in the drum, and it needs to check within 1%. I like to check daily with yield, meaning that you can kind of look at how many tons that run across your scale and how many tons you think you've run across your scale, and it needs to check within 5%. But the trick with this is anytime the silo is empty, you need to zero that out. So weight bridge is very important. Feeder bins is a huge deal for me because, like liquid asphalt, we run a lot of liquid asphalts. We run a lot of different aggregates. This is a Google Earth kind of angle shot of the plant that we lease through competitive bidding when we rebuild the track every 3 years. We got a lot of cold feed bins, and sort of a standard practice out there in the field is to say, well, we always run sand from these bins. We always run big rock and kind of intermediate size rock from these other bins. And we've got our calibration set up for those rocks, and we don't ever need to change that. And so when we started hauling material from all over the place with different crush shapes and different specific gravities, you learn really quickly that is not adequate. So, that's from my perspective at the test track, but from your perspective as a contractor on a profit job, if your aggregate supplier changes their crushing operation and the shape of the rock or the angularity of the rock changes a little bit, or the flat and elongated changes a little bit, that can change your bin calibration. Or if they get into some ledge in the quarry where there's a shift in the gravity, that changes your bin calibration. So you need to, there's a really easy way to check that in production. Main point is, I learned quick, size selected bins are not enough. You need to calibrate specifically for the aggregate that's in the bin. You also need to calibrate when you have a big mix change. In other words, a calibration that will work when you're feeding a bin at 20% might not work if you're feeding a bin at 40%, because the calibration can be rate dependent. The big check for me is that when I put a target rate in the plant that we use, the target rate and the actual rate need to compare within 5%. And that's a very realistic comparison target. In other words, my plant is rated at 325 tons per hour. We run slow at the track, so we might be targeting 200 tons per hour or 175 tons per hour because we're not running a whole lot of mix. Well, if I'm set at 175 and I run and my target rate and my actual rate is 145, then I know something is big wrong with one of my bin settings. And oftentimes that kind of data is ignored at the plant because we count on QC feedback to make adjustments to the bin settings. But again, you might have 1,000 tons out if there's, when you find out there's an issue with that. This is one of my favorite bin pictures because this is kind of almost a sand size rock mix here in this bin, and you see that water has collected on the bottom. The weigh bridge can't tell the difference between water weight and aggregate rate. All it knows is the moisture content that you've programmed, and then that means if you got water in the material that's flowing across the weigh bridge, the plant thinks that water is solid aggregates, so it's going to overpump liquid asphalt, and you're going to get an error in you're going to lose money on excess liquid asphalt, and then you're going to get hit with potentially pay penalties in the laboratory. But you need to make a note of the precise gate setting for your aggregates. You can calibrate the weigh bridge, or you can use scales and trucks to calibrate the bin setting. When you calibrate, and you need to be near your actual tonnage rate. In other words, if I'm running my plant on 200 tons per hour and I'm getting 40% of my mix from a certain bin, then the rate that's coming out of that bin is where I need to calibrate for that bin across the weigh bridge, and it needs to be within 2%. You need to have a good handle on your moisture contents, and then on the recycle side, all the same principles apply on the recycle side, noting that when moisture is high in your recycle stockpiles is higher than what you got set up in your computer, it's actually going to make AC content go down. So high moisture has the opposite effect on the virgin side that it does on the recycle side. And like if rain moves through, they're not offsetting. It's not proportional on both sides. So you have to be very, very conscious of that. And residual is super important. And then of course, stockpile uniqueness is also important. So we have a dust removal system at our plant that this is Alabama is a state where typically plants are not set up for dust removal, but we're running mixes for states from all over the country, some of which have really dusty stockpiles. So we set up a system at our plant that's kind of modeled after a fancier system that TJ has used for production mixes. And so this doesn't have this picture doesn't show the scrubber that's on it yet, but we have a dialed way that we can waste mix out of the bag, or waste fines out of the bag house return, and we've calibrated our dial setting using weights. So if I want to take 1% out, I know what the dial setting is on this bypass system, and it just dumps into a storage bin, and it's wetted in order to control the dust. On the dry feeding side, we've done work where we've just kind of lifted up super sacks and dumped them directly into the high-tech feed system. This is a much better way to do it, a much safer way to do it. Wreck the sacks in little storage bins that you have set up, and then feed that material into in this case into the high-tech system that then blows it into the plant. But whether you're doing the wet feed that I talked about earlier, or you're doing the dry feed, you need to make sure that the actual rate is really close to the target rate. And especially with these dry systems, you really have to monitor them for plugging, because if you're supposed to be running a dry additive in and the line gets stopped up, then if you don't have the alarms set correctly, or if you don't have a plant control based alarm system, you might not be aware of it, and you got a lot of tons of bad mix out there. So TJ, I think that is my last slide now, and I'm gonna stop my share, and I'm gonna hand off to you.
All right. Well, let's do this. Can you guys, everybody, see my factors to consider slide here?
Yes, sir.
All right, great. My volume's okay? Before I get into my slides, let me reiterate a couple things that Buzz has talked about. Everything that I'm talking about here is geared toward, the slides I've got are geared towards startup. The idea being that you want to be out of the box with good mix right away. Some of this, my contribution here is talking a lot about the physics of how these plants work. The hope is to put that on your radar screen so you consider it. A couple other things to consider. But before we get into that, let me back up and reinforce a couple things that Buzz has mentioned. I do a presentation called 7 Habits of Highly Effective Producers, and this came out of a request that was based on a lot of the auditing I'd done over the years of what is it that producers do that never have problems. And never is kind of a tough word to use, but they just hit the brass bell more frequently than others do, and have less stress. And a lot of the stuff that Buzz has talked about is what they employ. So on calibrations, I would sort of disagree with him in that you need to do calibration checks more frequently than what he's even suggesting. So let me add to the enforcement here a little bit. What we know is that calibration factors move. They move for physical reasons, wear reasons, all the specific gravity reasons that Buzz talked about. And so people that have less problems with their mixes are proactively, and that's key, proactively going in and verifying their calibrations. Now, when I'm training in some of the programs I put together for the state contractor qualification programs, I like to use the soundbite, checking ain't changing. So checking your meter calibration, checking your asphalt calibration, and yes, it's true, you need to check it for the different asphalt cements that you use and make sure that it's on target. Most of the plant automation will allow you to have 1 or 2 different asphalt meters. Yes, more and more people are putting in oversized meters and pipes, or a second unit for the asphalt cements that are drastically different. running through their metering devices. And this is true whether you're working with a Coriolis type meter, which Buzz alluded to, which is what's called a mass flow meter, or using a volumetric meter, which is probably more common, where it's a lot of guys call them pump on pump meters. The point is that a lot of producers are finding calibration tanks are relatively inexpensive. It's a real quick way to check your meter without having to get a tanker in. You don't have to waste any material. These are pretty inexpensive devices. More and more people are putting in pressure sensors. We've got a full set for the 3 plants that we operate. They're very accurate. They're made by several different companies. So there's a lot of ways to check the consumption on a run. It's also really easy to check calibrations. When you're on hold, what I've found, the people who do this, when they're on hold in the afternoon, thinking they might have made enough mix, not sure, might have to fire up again. And that's kind of what we're talking about here, is how to fire up out of the box really accurately. And that's what I'm going to try to contribute here. But in that time frame is a good time to check cold feed calibration for that aggregate, for that flow, belt scale calibration, asphalt cement calibration through the meter. None of these calibration checks really take longer than about 20 minutes. And so a lot of people just proactively try to do a calibration check once a month. So let me emphasize that. Now, there's a couple other factors to consider when we're coming out of the box on making short runs. So this would apply to doing a test batch, but it would also apply on a restart. And it would also apply if you're trying to run a couple short runs of mix, spring of the year, fall of the year, a couple, 2 or 3 different mixes. Maybe you have 3 silos and you're trying to do, well, I only need 100 tons of this mix. I'm going to go out and patch this job. I only need 6 tons over there. And then I've got to go over here and I got a larger production that I need to run. What are the factors to think about in the physics of the machine and the way this thing operates? First of all, make sure that your aggregate is consistent. Because these continuous plants, like Buzz said, they don't really know what's being fed through them. Make sure the plant is calibrated for those materials, like Buzz alluded to. He has an extra burden of switching materials, and it's true. Different materials can flow differently physically, even though they're near size. So I want to reinforce that. So if you have, this stuff is typically computer controlled now, and you can calibrate materials for different materials in the same bin at different gate settings. The databases with this automation now are very robust. And plant technology, here's kind of a flash. Working on this NCHRP project that Buzz and I are working on right now, became abundantly obvious to me, having to put it down on paper, that plant technology really hasn't changed a lot in 20 years. What has changed is automation technology. So even though we have, like, we run 20-year-old, 25-year-old plants every day on bonus mixes, but we have new automation. Just like your laptop got upgraded to Windows 10, you don't run Windows 7 anymore. These things, hardware has to be upgraded, and companies do conversions on controls, and they're typically in the $100,000 to $200,000 range. And you can have the latest and greatest control technology, and cold feed bins haven't changed significantly, or dryers haven't, or silos haven't changed significantly in the last 20 years. So it's easy to have the latest and greatest stuff. So you want to make sure that the calibrations are there, the aggregate's consistent, and now this is TJ's contribution. Want to make sure your timing values are set correctly. So if you want to, and we're going to talk about that just a little bit, how this works, but basically everything keys off the Virgin scale. And so the plant is set up with the latest and greatest technology, and once it hits the scale, everything else starts timing. So setting those timing values correctly will maximize your accuracy, and it minimizes magic mix between changes or on short runs. So, and I'm going to show you a couple pictures, try to illustrate that. This is a very, very important point. And a lot of times I built plants for years, and I'm still involved with rebuilding plants. And a lot of times we're really, really pressed, and out of the box, we sort of know where to set these timers, and we're 2 weeks behind. We got to get production, schedules being impacted. We'll get around to changing them later. I've seen a lot of plants where those timers never really get adjusted right after the fact, and it's kind of confusing. Usually I have to be involved with the manufacturer who really, really understands how to set those timers, and that will minimize the amount of out-of-spec mix as it works its way through the plant. You've got to allow for kiln travel. Okay, big rock goes through dryers more quickly. So there's some crazy stuff going on here with a kiln. You've got an airspeed inside that kiln in the combustion area that can approach with the expansion of air and steam, water to steam, can approach 60 miles an hour. The exit of those dryers have an airspeed of about 20 miles an hour. Typically is kind of the design, 15 to 20 miles an hour for most manufacturers. But guess what? You start feeding material in that plant, the big rock is not going to have a problem. It's going to, first of all, when it goes down through the drum's at a slope, usually 3/4 of an inch to a foot, sometimes 1 inch to a foot. And big rock is going to tumble downhill through that drum more quickly. And it's not going to be impacted by that airspeed, which is going to hold back the sand and dust particles. So when the mix comes out of the plant, it's going to look black and shiny if the timers are right, but it's going to be short of fines. And so you need to understand that, and you got to allow for that by having your drop gate open. And you can test this if you want. You can build a sample device that's sort of like a shuttle buggy or a material transfer device. Insert, put it in your loader bucket, go to your drop gate, fire your plant, get a sample, set it aside, do it again, do it again, do it again, and you can figure out what your time value is where the material is stabilized. So you don't want to just put someone at the discharge chute and just watch for coating, which is important, but that person has to have an eye for the fines. Controlling temperature is also important because temperature is a spec. Temperature really affects your fuel density. A good operator knows at that rate, with those kind of moisture conditions, with that kind of mix, where to set that mix temperature, and not wait, well, I'll just keep making more material, make more, eventually my temperature will get there. So if you really challenge an operator, and I do this usually by showing up with a $50 bill and throwing it on the counter and saying, you really can control temp within 10 degrees. Nah, it's hard. It's like, really. And if you get this waste down to, say, 10 tons loader bucket, here's 100 you can take home. I've never seen a guy not get that within a day. So it's just a matter of learning your temperature, and learning your kiln travel is real important. And then you want to charge the silo for at least 4 loads. And I'm going to explain why. 3 is your bare minimum. You want to have, and I'm going to show you an illustration on that. So you want to lose your first load in the cone, because the cone's going to be slightly segregated. And I'm going to have some pictures I'll show you, illustrate these points. You're going to lose that load. You don't want it to go to the yard, out in the field. You want to make sure you have a load over the top of that cone, because otherwise it's going to rat hole. So we all know about end of silo segregation. So what you want to do is you want to put it in the silo. You want to build a head of material. You want to lose your first cone. Make sure there's a head up there, and that'll squeegee it down through that silo opening. Your second load then should be good. So if you get good at this, You can lose the first load, second load's sample load. Now the question becomes, how much do you want to maintain over the top of that cone? We always do 4 loads. When we do a trial batch and we're checking out a mix, we always do 4. It's just our culture. We're really, really scared and we want to get 2 samples, we'll put 5 up. That's on setting up a mix, kind of like what Buzz would be doing. But we have many times sampled the second load and it's been fine. So when you get good at this, you can handle it. So a couple slides here that just kind of illustrate. I popped these out this morning. It's not Buzz's plant. It'd be better if it was probably, but here's a real super long drum. It's got an outside mixer. This is your drying kiln. This is where asphalt's being mixed at this plant, but turn around and go look at this thing. And you got virgin rock coming in this end. You've got your wrap coming in over here on the right of the screen. And there's your drying kiln. So this airspeed is going to develop. This moisture is going to expand from water 1,600 times. It's going to create its own airflow. You've got to evacuate the steam out of the system. So you got a dust collector here and an exhaust fan on the other end. You got to draw that out. Materials coming from the feed bins. And once it hits a scale right here, it's going to start counting. And it's going to say, okay, I need to turn on the recycle bin after a certain amount of time because I've measured this time through this kiln. And then we've got to get the asphalt pumping system ready. We got to get it time done. The additives like Buzz is talking about, whether it's liquid, whether it's a filler that's being added, or whether you're going to put fibers in, This is what one of those screens looks like. So this is the screen where you set on this particular plant. This is the screen you go to set all these timer values. And if you just look at that really quickly, you'll see there's a bunch of seconds listed there. And I could explain to you in more detail how this is really done, but for the sake of time, you get the point. Inside shot of the kiln, just to illustrate the fact that this aggregate is going to tumble down toward that fire. And so it's pretty easy to envision the concept that when it starts, there's going to be sort of a vapor pressure in there that's going to hold that dust. And let me try to do my hands right. It's kind of holding the dust back. Once you load the drum up, it pushes through. And so this is why we can make excellent mix. It's that first startup. And this is why it's really better to not clean out the drum when you do a mix change, because you keep that kiln loaded full of material. So now more pressure on being organized, switching from one mix to the other. You're still going to have a little bit of overlap in there. And that's what you learn how to manage. And you can test it for your plant, for your type of aggregate, when that overlap, mix really how much of that there is. Generally, with the automation we have today and the equipment we have today, we can get that dialed into about 10 tons. A lot of people will argue with that. That is like kind of the best case scenario. I would not ever subscribe to the idea that it could be less than 10. Generally, what I try to do is shoot for like 1 load, okay? And then it's a question of what am I going to do with that load? It's not perfect one way, it's not perfect the other. What am I going to do with it? What a lot of people do in the field is they'll use they'll have an extra silo and they put that crossover mix in a silo, and they might let just a little bit of it into the larger mix that they're shipping that day, not a full load. And dilution's kind of the solution, and you're still going to be, in spec range. If you're working with a material transfer device, boom, problem solved, because you have a chance to get a little bit of remix going on there. So you have to make an executive decision on what you're going to do with that, okay? But it's physics that affect this thing. Having a guy at the chute measuring temperature, he's going to tell you your temperature is good, and he's also going to be watching that mix, and he's going to be saying, okay, we're coated, we've got fines now. Again, when you have that kiln completely loaded, then, and you do a change, you can make a short change, and you don't have to worry about that draft problem that occurs inside that dryer. When it comes to the silo, 3 pictures here, there is a cone inside that silo. So generally with this particular one, it's about right where that line is. It looks like a square cylinder, but it's not. There's a cone up there like I've illustrated. And then the question becomes on the right-hand side of the screen here, how much mix do you want to put in there? When that material drops out of that batch or down into that silo, it's going to roll out a little bit. And so you can sort of envision what's happening here. That mix, that first load is not going to be perfect while it creates that movement. Okay, you get material, you look at the right-hand side of your screen, you get material over that cone. Now you got pressure. When that stuff comes down, it splatters. So you're dropping a whole load at once, and it just kind of goes sideways and stops in that silo. When it unloads, there's going to be hydraulic pressure that pushes down through that opening. Because that opening is smaller than that silo, that's what causes the very mix at the end to rat hole out. Any larger aggregate that traveled further in this silo when it charged is going to be on the outside, and it's going to rat hole out. So you don't want to count on that last load. A lot of states have specifications. You can't ship the first load, you can't ship the last load. So in summary, my points are, make sure everything's calibrated and reinforce everything Buzz is saying about calibration. Make sure your timer values are set right. Understand there's kiln travel. Put someone there that's watching that shoot for the good mix. Okay, I think we're good to go to silo. It's a visual thing. You can figure this out for your plant. Make sure you have an operator. That's an operator skill set. It's not an automation skill set to control that temperature, and then figure out how much mix you're going to make. Buzz, it's yours. Stop share. I'm sorry.
It's okay.
I'm not very good at this.
No, you're great at it, TJ. This is excellent. Excellent presentation. Appreciate it. You're spot on. Can you hear me okay?
You're good.
Okay, great. Good deal. So my job now is to kind of put all this together with some implementation takeaways. What's the low-hanging fruit for everybody? Well, high quality, fast startup is great for both profit and for sustainability, because we're not wasting material, and we're making more money when we do that. This is big for me. I think TJ and I agree about this. Proactive setup and calibration is always better than reactive tweaking. It's really lazy to just kind of react to what you're measuring in the lab and make relative changes at the plant. Let's get set up first, and then we can make mix changes, knowing that knowing the plant is doing what it's being told to do. Statistical understanding of gradations, moistures, and residuals is really important. Understand how much variability you've got on your yard, because you don't want to measure, run mix, use good principles, run mix, measure something in the QC lab, and then make changes based on what you're measuring in the QC lab, when really what you're seeing, the difference you're seeing in the lab might be variability on the yard. So be really conscious of that. So my focus was the kind of look back a little bit this morning. My focus was the liquid asphalt pump, the weigh bridge, and the feeder bins. And TJ, I'm speaking for you here, hopefully accurately, but your focus is sequencing materials through the plant properly, and timing is a very, very important part of that, and understanding physically what's happening in the drum as you run mix. I think this is very consistent. TJ and I are exactly on the same page. You can expect to waste at least 10 tons, and you can do it in 10 tons, but 20 tons is probably a better guess of waste tons in a hot swap if best practices are utilized. We kind of use that same rule of thumb with startup when we're starting on a new mix. And exactly what TJ said, like what I like to do is put my mixes together so that I'm not cleaning the plant out, and I'm allowing for 20 tons typically of transitional quality when I go from one mix to another. But if you can avoid having to charge the system again with all new material, then you can do that even more efficiently. I use 20 tons because I think it's really taking 10, and so that's a conservative waste for me, and that's just because I'm trying to hit quality as perfect as possible. And I look at these things as efficiencies that are double green, right? They're green on the environmental side, the sustainability side, but they're also green on the profit side, because when you take these extra steps, you do the things that we're talking about. One of the underlying themes here is you don't have to waste any material to do any of this stuff. You just have to take the time to do it, because when you run material across the weighbridge to check the calibrations, you're not contaminating that material. You catch it in the truck, you put it back on the stockpile. When you're checking AC, you pump that material back into the storage tank. You're not wasting any material. And I really like what TJ suggested about saving that material. We got 2 silos, and we do that type of work as well. We use one as kind of our workhorse silo when we're building the track, and the other one is a transitional silo, exactly like he described. And then I always end with making this statement. Really, what all this is about is safe and sustainable asphalt pavements at the lowest possible life cycle cost. And I think that this discussion about being good fast at the plant is a perfect fit for that. Before I move on, TJ, is there anything you want to add to
No,
these
it's good.
takeaways?
It's good. I think it's a good summary, Buzz.
Good deal. Thank you so much. So if you want to do a screenshot, that's our email addresses, and Travis is going to jump in here for question and answer. Here, I hope, yeah, Travis is back at his desk, as he and I are bouncing around doing a couple different things here at NCAT today. But before I hand it off to him for Q&A, because I know there are some questions in the box there. We're promoting the end of cycle track conference. It's May the 7th, 8th, and 9th of 2024. And I'm told the registration is live for that now. So I need to probably add a QR code or something, Travis, to this slide that I show in the future, so that people can go and get registered. We are going to have exhibitors and everything, but mainly we just want people to be aware to avoid conflicts. We're promoting training in your pocket. Travis said this morning he's getting really close to 1,000 people that are now following this, and that are kind of registered for the channel. And TJ, people like him, that are engaged in this type of work. When you hire new technicians, there's a lot of really nice, short, engaging, amusing videos that teach some good basic principles in an entertaining kind of a way. So y'all check that out. And then NCAT, we have a lot of training courses that we offer. Travis is our training director, and we do training here. We do training at your shop, and then TJ does a lot of speaking and a lot of consulting. So you got his email address if you need to follow up with him about any kind of technical support or training that he can provide. And then finally, here at the end, we normally do this every month. We've changed December because December is challenging for many of us. The next one of these is going to be the third Thursday in January, which is January the 18th from 10 to 11. And the theme of the next one is expanded use of locally available virgin aggregates and recycled materials. So it's the focus of this next one really is what tools can we use to innovate. That's important for agencies to understand, to have the right specifications. And it's also important for industry to understand, think outside the box, if you have the specification flexibility to be much more efficient. So Travis, I'm handing it back off to you.
Great. Thank you, Buzz. Thank you. So we did get a couple questions in, and I'm excited to hear some of the discussions here. So we got from David Walker, who makes the dust removal system or the scrubber that you guys were talking about?
TJ, y'all have 3, right? So
yeah,
why don't you field that one?
Call Buzz. Buzz has got some emails. So we sort of had to build one so that the easiest way to do this. We started doing this a number of years ago in Florida. A lot of people just couldn't. We had to run in higher percentages of wrap. The dust is bound. So to hit your dust to binder ratio, when you run at higher percentages of wrap, particularly, a lot of times you're going to take some of that virgin dust, not put it back through. Basically, what you waste, the easiest way to do that really is very simple. Take a thing called a mixer screw. You can look this up with Martin's engineering book. We use some hydration nozzles with water. That's kind of, we probably ought to do a whole separate, topic on that. But Buzz has got an email from me and you can reach out to me. It's very easy to do once you know how to do it. And basically it makes that dust just sort of like paste. And the key is the size of the nozzle. The key is the nozzle distribution. So Buzz is calling them scrubbers. It's pretty easy way to do that, and you don't have any ambient dust. So reach out to us and we'll try to fill you in more in detail on that.
And yeah, ours is just a vane feeder, and TJ's absolutely right. I think we were in Virginia when you kind of put me onto this. You showed a picture in our presentation that you were doing about what y'all had used, and we just bolted onto the maintenance port at our plant, and we're just dropping material out of the bag house for return in a vane feeder that's got a RPM controller on it, and so we control how much material we're using by that, and it was relative. What we did was relatively cheap, so it's not expensive.
The key is the rehydration. Otherwise, you're going to have PM10 problem. You're going to have visible emissions. You're going to have a doses exposure. So the key is to rehydrate. The slide that Buzz showed was prior to his rehydration. It's the rehydration we're talking about.
Okay, great. Okay, so the next question we have from another David is, to the point of traveling through the drum, do you have any input on adjusting the material timing to allow for your fines to kick on sooner and allow that larger aggregate to catch up?
It's really hard to do. We've done it. I've done it. It's a very involved process. Usually we put fine material on last from the feed bins, and that's to keep it from sticking onto the belts. So because there's negative repercussions if you do that. After you can do a mix change with another set of algorithms, but it's so hard to time that most people don't do it from a practical standpoint. I would, if you really want to pursue that, what you want to do is talk to the people that make your plan automation, talk it over with them, expect to be shocked when they tell you, why would you want to do that? And but they can work with you on that. So what you want to do then is but that's why I stress the fact that when you do a mix change, you don't have so much of this issue, because your pressure inside the kiln is basically the same. It's usually on startup where you just have this issue. And if you can learn the amount of waste, then you kind of manage it that way. So what you have to do is you have to put sand in first, right? And the fines in first. And it becomes kind of counterproductive anyway on startup, because they're going to get sucked back anyhow. And then the big rock's going to push it through. And on the street, you hear guys say, well, the rock pushes it through. Well, it's really a matter of, once you stabilize that load pressure, then the fines don't have much of a problem. If you can imagine, like shoveling material in a wind that's blowing 30 miles an hour, you learn pretty quickly you don't want to shovel it in front of you. So it's really that matter. Now it all works out. I mean, it all works out. It's only on startup, which is what Buzz and I are talking about here. We're just making people be aware of that. And you're going to lose the cone anyhow. So if you lose the cone anyhow, and you have a hole watcher, generally you're not going to have an issue. Well, what do we do with the cone material? Well, we recycle it, right? So you're not really wasting aggregate. You're not really wasting asphalt. What you're doing is you've got a crushing cost, a sizing cost. You got to re-dry it. You got to re-electrify it. So it's not like you're throwing away $75 material. You've got a cost that's arguably somewhere between $5 and $10 a ton to be able to utilize that later. You put it into milling hill, and statistically, it's going to disappear. Hope that was an adequate answer.
Great, great. So next question I see came up here from Jeff. It says, are you testing volumetrics at the point of placement or from trucks? And how do you ensure that you obtain a representative sample? So Buzz is testing from multiple spots. I can tell you that, where we don't have audio from him, especially on the track. They're pulling at the plant and trying to get it immediately, but they're also testing once we get to the track site and dumping it into the QC lab as well there.
Yeah, when we troubleshoot, what do we do? I mean, and when we're worried, what do? We sample everywhere, right?
As soon as possible.
So sample out of the truck, make sure it's done properly, whether you're in a state that requires it or not, and then we go out and measure out of the paver. And even in states where, you know, they don't necessarily do that, if we find issues, then we have to have data. And if there's a difference between what's in the truck and what's on the mat, then we've isolated it. Troubleshooting is really just a matter of, you know, narrowing it down until you get it between 2 points, and then you go find your problem. So there could be paver issues, there could be paver practices, but pavers can't fix bad mix, right? But you know, so, you know, do both.
So what would you expect waste to be at startup each day if the mix design is the same as the day before?
Well, first of all, what you want to make sure you do, which we didn't talk about, is you want to get the guys, and they're generally, plant guys are very cooperative on this because it makes sense to them. You want to make sure that you slow the plant down to your startup rate the day before, because that loads your baghouse dust level for the ton per hour that you're going to run. It matches. So if you start at 200, you ramp up to 300, you want to ramp down at the end of the day as you're shutting down a little bit at a time, and that gets your dust load on your dust return the same. You should be able to manage 5 to 10 tons of waste. I lost a bet one time with a guy because 5 tons to me is like that superstar status, right? And I lost a bet to a QC manager that knew how to run a plant at 500 ton an hour on a 350 ton startup. And he had less than 5 tons of waste, and the mix was perfect. So I tell guys that they should be planning on 5 to 10. That's a good management target. And a lot of people will say there's no way I can do that. And there's your opportunity for improvement, right? Because my experience is we can get anybody to 10 tons, but there's a lot of training involved. You got heat, you've got to learn how to run your burner, you've got to get all your timers right, and you got to learn how to come out of the box with your heat. And that is a real skill set. I mean, that's an art. And so I think that's a practical goal. I'd say anybody that set a goal any tighter than that, I'd really want to argue with them, or whether it was practical or not. 20 tons of waste is very common in the industry. 30 is not uncommon. When I audit a plant, I always look at the drop gate, and if there's more than a dump truck in there, that I'm asking questions why, because I know there's an opportunity for improvement. A lot of times it's just a training thing, or it's a timer thing.
So given that, we have a comment in there, but I can't make a question out of it. We're 5 minutes over, so I'm going to go ahead and we're going to shut it down. Please feel free to reach out to any of us. Buzz shared the information on how to reach us there. I put my email in the chat box. A couple of people are asking for the recording. If you email me, I can give you a copy of that recording when we've got it ready for publish, and we'll go from there. TJ, thank you so much for joining us. Great information. I think this has been a great webinar. It's fantastic. And Buzz, always great to see you and have you around. We're glad we get to keep you, and retirement hasn't pulled you completely away.
Can I ask a question of you, TJ, before we bail on this thing?
If Travis will let us.
Yeah, of course. Let's go.
Is it worth it to have a separate mix design set up for startup to try to control how you're feeding the drum and handling the the pushback and all that stuff, that you start up on one and then you hot swap immediately to another? Is it worth it to do that? Because that might be a really simple way to transition in.
Yeah, that's basically what you find most producers doing. And they're generally going to start up on a commercial mix. There's always somebody that's going to come by and buy that particular material, get their temperature. Frequently it's a finer mix that's got more sand and dust in it, right? Less rock. And then when they switch over to a coarser mix, they're loaded. The kiln's loaded and everything's good. Okay. So I think they do that. They've learned to do that. It makes it a sellable mix. It's sort of a non-spec, it's not like going on an airport. And they still frequently, you have a lot of people losing the cone though, still losing the cone, and then they switch over. So yeah, Buzz, it's a real practical way of doing it.
And I lost some of my audio, but did y'all address the question about what happens when the baghouse, when dust wasting reduces the aggregate to below 100%, and it causes the AC to bounce around? Did y'all see that question?
So we saw that as a comment. I couldn't form a question out of it, but if you want to address that, that'd be great, Buzz.
Well, what it looks like, maybe that was a sort of addressed to me in that device that I showed. And when you lose mass, when you got weight coming across the weighbridge in aggregate and you remove some of that mass, the plant doesn't know that. So it then is going to change the amount of AC that it's pumping in. How do you account for that? And I think you can account for that mathematically with the AC that you set up on initially as your target. I mean, you can get feedback from QC and make a tweak to your binder content. But what I would do on my side is I would just hand do the math and say, what kind of a correction do I need to make to my total asphalt content setup in order to handle that. Now, if it's bouncing around on you, that's a whole nother issue. But TJ, how would you respond to that?
Well, it's generally not as big of a statistical, a mathematical problem as we think. Only about a third of the dust, when the plant's properly balanced, ends up in the dust collector in the baghouse. So if you're looking at a 5% AC and you're running a dust to binder of 1.2 to 1, you got 6% dust moving around. Maybe you're making dust another 1 or 2%. Then you can do what Buzz says. But if you lose 2% of your feed on a 5% AC target, on your scale, it's only going to affect your AC a tenth of a percent, arguably within the testing parameter of the equipment that we use. So it really doesn't, because kind of like a moisture situation, it really has to be egregious to be a problem. Now, the automation is set up so that you have two choices. You can either have that dust removal percent that's running your variable speed airlock is then automatically adjusts the scale based on a tested value, which is set up in the automation that gets you even closer, or you can weigh the dust out, put it in a storage device, weigh it back, take it off the scale, store it, put it back on the scale, and do your dust that way. So it's been done a lot of different ways, and it can be managed like that. But a lot of people do wing it because they're not taking too much dust out. It doesn't really affect the final AC that much. So I hope that's a thorough answer.
Yeah, thank you for that, TJ. I appreciate the extra time, Travis.
Okay, sounds good. So everyone, I'm going to wish you all a a wonderful holiday season, and look forward to seeing you back here in January. Buzz?
Buzz,
right,
Travis,
yep.
Buzz and
Yep.
Travis, thanks for letting me be part of this. It's great. Thank you.
Thank you so much, TJ. Everybody have a blessed day. Talk to you soon.